Hello 108 students, Mr. McHugh back here with you on section 9.4. We are going to tackle page 3 here as we're working our way through the middle part of this section, and we left off with example number 2, and we had two students who had traveled north and west. You remember the drill. They were 100 miles apart. Their GPS app told them that. And the distance that the student going west, we labeled that as X, and the student going north, we knew it was 20 miles more, so we were left with this last equation. Okay, now, so 100 squared is 10,000, X squared, nothing to do. Now, what about this? X plus 20 quantity squared. Look at the side work details. A, you could use FOIL, a binomial times a binomial, and then use FOIL first, out, or in, or last. Okay. How about this? Don't you have a binomial squared? How about this idea? Take the first term, square it. Multiply the two terms. X times 20 is what? 20x. Double it. There you go. There's the work right there. And take the second term and do what? Square it. Bottom line, what do you get? X squared plus 40x plus 400. Little details that you got to make sure you get right. So there you go. I substitute that in. And I know I'm dealing with a quadratic. Okay, you see those exponents are 2s, so combine like terms. Can you solve this equation? I think you can. So what I did was I noticed it's a quadratic. I minus 10,000 on both sides, and I combine x squared plus x squared, giving you what? 2x squared. 40x comes down. 400 minus 10,000 is a negative 9,600. Okay, now this next step. You look at that and you go, oh boy, I see a 2, a 40, and 9,600 for the coefficients for A, B, and C, and I'm like, you know what? Before I factor and do reverse FOIL, can I not always do rule number 1, which is look for a GCF? And the answer is yes. Okay, you could pull out a 2. Another way I like to teach this, and I'll do this in the next example, because what happens here is this 2 is a factor, there's no variable, and what you're going to do is you're going to leave it, and then it's just going to drop out, and that freaks students out. They don't like that. And so what I like to teach now is when you see that GCF in an equation, you pull it out, divide by 2 across the board. Okay, either way that works for you. Either divide the whole equation by 2. Look, every term divide by 2. What's the result? 0, and you get the quantity x squared plus 20x minus 4,800. Okay. Now, if you like pulling out the GCF, just be okay with it sitting there, and you're just going to drop it. Either way works. Okay, now the key thing here is, can you factor this trinomial? And the answer is yes. 48, think of 8 times 6. So I'm trying a plus 8 and a plus 80 and a minus 60 for the 4,800. And you do the outer and the inner, and you know the drill. Make sure you unlock the safe and get 20x, and that combination works. Now, you've done this hundreds of times. What do you do with the binomials that you have that multiply together equals 0? You got it. Take the parentheses, set them equal to 0. So you got x plus 80 equals 0. Solve for x, minus 80 on both sides. You get negative 80, add 60 to both sides, and you get x equals 60. Okay, now, what do we do with this x equals negative 80? Think about this. We're talking distance. Can you have a negative distance? I've already kind of hinted it to you. No negative distance. So now this is your part of your answer. This was the person going west. If they were 60, the other person going north was what? Remember, you got your MSI hats on. 20 miles more. 60 plus 20, 80. And there's your two answers. Okay, there you go. You helped solve that. So now they can make a decision. Do you think it's better for them to go all the way back home, or could they? The problem is they might not have no choice though, right? Because here in Idaho, you can't just cut across the mountains on your road. So. Okay, so now we go to example number 3, and objective number 3, area formulas, and let me make sure it's example 4 in the book. Yeah, example 4. Okay, I love this problem. So here we go. I usually tease the class a little bit. I get the ladies involved. They'd like to have a pool, and they go out there, get their husbands and boyfriends, and they're going to help them build a pool. And the problem is they built this pool and they want to do something a little bit unique, and they want to put a grass strip all the way around the pool. So we're told the pool is 20 feet by 30 feet. Okay, no big deal. We're told we want a strip x distance going around. Think of this like a picture frame, and our job is to find that distance x. Now here's the thing that's given to us. For some crazy reason, that the area of that x strip has to be 336 feet squared. Now where in the heck did that come from? Well, it's given to us, so at some point you might say you don't have to care about it, but I tease the class and say that's one bag of grass seed somebody has saved up, and that's all they want to use. They don't want to spend any more, and I laugh at that when they're spending thousands of dollars to build a pool. They don't want to buy another bag of grass seed, but what would that width be? So you're talking to them and you go, I think I can help you out. So what do I suggest in these problems? A diagram. Okay, draw a 20 by 30 pool. Draw the big rectangle going around it. Okay, let x represent what? The grass strip. It's on all four sides. Okay, now you've done that, and then we got to think about this now. What would the length of this grass strip be? You got 30 feet, the pool, length of the pool, and then you've got the grass strip on the left side, one on the right side, so you would have what? X plus x, or 20x. So there's your 30 plus 20x is the length of the big rectangle. The width of the pool was 20. Add another x and x for the length of the grass strip, so you have 20x. So you've got 20. You cannot read that. Sorry, 20 plus 20x. Okay, so those are your dimensions of the pool and the big rectangle going around. Now here's the moment you need to have. You come down here and you look at this equation. This is what I call the strategy equation. Okay, you need to think about this and ask yourself, if I knew the area of the big rectangle, and you go, well, area of a rectangle is what? Length times width. Okay, that's in your toolbox. It's assumed you got that. You've done hundreds of those problems back when you were in like 5th and 6th grade. Now, do you know the area of the big rectangle? Well, we know it's what? 30 plus 2x times 20 plus 20x, or 2x, excuse me, 20 plus 2x. And that's how we would figure out that area. If I knew the area of the big rectangle, and if I took away or subtracted the area of the pool, which is the 20 by 30, so multiply those two, what would be left standing? So think of that as a stamp. If you had a big rectangle and you punched out that pool, the pool, you'd be left with what? The grass strip going around. And there's your strategy equation. The area of the big rectangle minus the area of the pool would be the area of the grass strip. Okay, once you've got that figured out, now you're on the way to plugging in. So the area of the big rectangle, we already talked about that. You have two binomials, we're multiplying them from now, I'm not freaking out about it. Area of the pool was 20 by 30, so you're multiplying. The grass strip you were told was 336 feet squared, and I tell you that I believe that's like one big bag of grass seed. Okay, so what do we do now? Got your equation wrote out. What happens when you multiply a binomial times a binomial? Do the FOIL method: first, outer, inner, last. Okay, you can follow that and get those numbers. And I got 20 times 30 is 600 equals 336. I noticed that the 600 and the 600 with a positive 600, negative 600 cancel out. So I'm left with 4x squared. Remember, I see a trinomial. I put them in descending order. 40 plus 60 is 100x minus 336. Ooh, I moved that over because I know a quadratic's got to be set equal to what, class? Okay, 0. You know that from the standard form. You know that's where the graph crosses the x-axis. Now from here, here's my magic. I see 4, 100, 336. I double check. Can I divide all terms throughout the equation by 4? Or I could pull out the GCF of 4. Doesn't matter. Bottom line, you resimplify your equation. I strongly recommend you do that, because now you got x squared plus 25x minus 84 equals 0. Now you look at that for a second and you're like, ooh, I need to reverse FOIL and factor it. Give yourselves a set of parentheses, and 84, a tad tough, but if you take 84, 3 times 28, look, what's the sign? It's positive 28 minus 3. Multiply them together gives you negative 84. Add them up will give you the 25x that we've done hundreds of times. O and the I must add up to the middle, and that is a true statement. So now you take the parentheses, set them equal to 0. Of course, you can't have a negative distance because it's a physical problem, so that's out. And so your answer is 3 feet, which would be equal to what? Who can help me out in yards? Oh, I gave it to you. You guys knew that. Okay, Mr. Q, a little long on that one, but excuse me. We have finished up page 3. Okay, good job, everybody. I'm going to sign off for now, and I will see you for page 4. And I think we're going to do some more application problems, quadratic functions as a model, as I'm looking at. Okay, I'll see you then. Bye.